Okay, here there are two examples. In the first case, we are asked to determine the total charge, or Q. So we are given, let me just choose the color. So we have constant current, and then again constant current. Let's say this is, this is a time t, and the current I. So this is 10 amps. Let's say this is 5 amps. Now this is 1, this is 2, this is 4, and this is 5. So the question is, determine the charge when T1 is 0 and T2 is 1. The second question is again the same thing. Q is how much when T1 is 0 and T2 is 3 seconds. So to start for the first case, between 0 and 1, what we have is this 10, and that's it. And this is 1. Is 10 amps. This is time axis. Between 0 and 1, the current is 10 amps. Now we know Q is integral of I dt from 0 to 1. So this is, in other words, the same as the area under the curve, right? I dt, the area under the curve. So this is area. So the area is technically 10 times 1, right? So this is 10, horizontal is 1. So this is 10 times 1, which is 10. So the unit is 10 coulomb. Yeah. So this is 10 coulomb. In the second case, we're asked to find Q between 0 and 3. So 3 is somewhere here. So we are asked to find this area. So in this case, if you see, there are 4 areas. So the first one is this area. Let me use a different color. So this is the first area. A1. This is the second area, A2. This is the third area, A3. And the fourth area is this one, A4. So here also, let's see. Here also, this is for the second, let's say, first case, second case. So this is first case. For the second case, Q is the integral again from 0 to 3 I dt, but now I has different values for different areas. The first case, between the first ones, 0 and 1 second, it is 10 amps. Between 1 and 2, it is linearly decreasing, and between 2 and 3, it is again constant. So it changes with different time, with a different interval. So therefore, this is technically from 0 to 1 I dt plus 1 to 2 I dt plus 2 to 3 I dt. So we have different currents, or we have different expression for the current in this area, or in this interval. Now in the first area, so this is technically A1, this is technically A2 plus A4, this is A3. So A1, A2, A3, and A4. So A1 is 10 times 1, and A2 is 5 times 1, and A3 is this one. So this is let me just say A4. A4 is half times base is 1, height is 5. Plus A3 is the 5 times 1. If you add this is 10, 15, 20, 22.5. So the total charge that will be stored between 0 and 3 seconds is 22.5 coulomb. That's for the first case. Now in the second case, we are given the current I, which is 5t minus 1 times t, and the voltage. And the question is determine the power when t equals to 5. Now keep in mind, this is millisecond. That was the only thing. That's the only thing we need to be very careful. If you just forget the milli, then the answer will be completely different. So in this case, I is 3t minus 1, and V is 20 volt. This is 3t times 1 times t. So power is V times I, and we're asked when t equals to 5 milliseconds. So what I will do is 3 times 5 times 10 raised to minus 3 minus 1. T is again 5 times 10 3. Now this is 5 milliseconds, which is 5 times 10 raised to minus 3 second. So always we are given in terms of milli, so we have to convert that into second first. So once we do that, then we just the rest is simply plug in the values. So this will be approximately close to minus this multiplied with, so this is I, and we have to multiply with the voltage, which is 20. So this is approximately minus 5 times 10 raised to minus 3 times 20. Then if you multiply that, you'll get the answer. So this is equal to minus 100 times 10 to the minus 3. This is now power, so the unit is watt, or minus 0.1 We were able to determine the power at 5 milliseconds given the current and the voltage. So that was the question. So I hope this example will help you to solve homework problems.